Good morning. Let's have a class today. And I will say today's class is important because we're going to talk about very important staining technology, which is called the gram stain. So we'll move to that section. So that is we call lab 3 gram stain. And this is in line with our lecture. In the lecture, we're also going to talk about the detail of the gram stain, okay, and also other staining technology. So first of all, gram stain is developed by Danish scientist Chris Gram in, I believe in 1884 in Berlin. It is a very magic tool to differentiate bacteria into two groups. So it is a differentiated stain. It differentiates bacteria into two groups, which is gram positive. Gram positive stays stays purple because crystal violet color. So it stays purple. I'll just put a quotation mark. And the gram negative bacteria, it stains pink or red. I would just say it's a saffron in color. And this is for bacteria. Now for fungi, we just make sure it's easy. For fungi, everything we call gram stain blue. Okay? So we're not going to do the fungi here. We're going to focus on the bacteria. So we talk about gram positive and gram negative. And the principle behind why the gram positive bacteria will stay purple, gram negative bacteria will stay pink and red, you may learn in other classes. This is talk about these two theory, which is we call it a cell wall theory. Because gram positive bacteria has a heavy peptidoglycan, and the gram negative bacteria is very thin peptidoglycan. So they cannot hold on during the decoration process. So the dye is washed off. And finally, you counterstain with saffronin, it shows you saffron in color. And the detail we will talk about in the lecture. The second theory, we call it a lipid theory. This is, you may not have heard about before. So gram positive bacteria, the lipids amount is about 5%. And the gram negative bacteria, the lipids amount is about 10 to 15%. The reason is gram negative bacteria, the outer layer have lipopolysaccharides. The major components of that is lipids A. Because gram negative bacteria has a huge amount of the lipids, so during the decoloration, they together with the dye crystal violet is dissolved in the alcohol. So it's become a blank, and you counterstain with saffronin, it showed up. Okay? Very briefly talk about that. So we're going to move on to the major procedure of gram stain. The major steps. And this you should be remember, it's absolutely will be in the exam. So you should be remember them very clearly. Okay, what are the major steps? Of course you have to do air dry heat fixing the smear preparation. So that's, we skip it. The major step to stain is the first one, crystal violet. Crystal violet is a function. This is a basic dye. Okay, basic dye will put some color onto the bacterial cell wall surfaces. We have to put something there. The second step is we're going to add gram iodine. So I'm using this color, which is add gram iodine. Gram iodine, usually it's a brownish color. It's called mordant. And we want to make crystal violet stay, or we say stain strong. Okay, the third step, which is using 95% alcohol. And this step is called decoloration. Decoloration has to be very short, because if it's very long, everything will be moved off. The last step is using a very pink or a little bit red dye. We call it saffron. And saffron, we call it a counter step. Okay, those are the major steps. Now, how are we going to do it? Today, the lab work will be very similar to what you did on Thursday, but instead of using a simple stain, we're going to do the gram stain. So this procedure, very much similar, but there's a little bit difference, so we wanted to emphasize something, okay? First of all, this you may not see it. First of all, is you're going to get a glass slide. The same thing. The glass slides, you're going to draw two big circles. Left side, we're going to do E. coli. Right side, we're going to do lactobacillus. Okay, now second thing, we flip it over. Flip over. And then we're going to add a smear there. So how are we going to add? If we flip it over, very similar to you're going to have LF here, maybe EC right here. So you add a drop of water, and then you also going to add a bacteria there. Okay, bacteria is on the slants. So two different bacteria, which is E. coli. We put EC as an acronym, and lactobacillus. And this is why we put the LF there. So we're going to add there, and make a smear. Okay, so that's called the smear preparation. Once you make a smear, you don't forget about what we did before, is air dry 3 to 5 minutes, and then followed by heat fixing back and forth on the Bunsen burner to inactivate enzyme, let the bacteria stick on the glass slides. Okay, then we move on to the major steps. And the major steps we already mentioned, we're going to review again here. So number 1, crystal violet. Crystal violet will stain 60 seconds. Number 2, we're going to add gram iodine. 60 seconds. And you have to do a gentle rinse between that, okay? Then you're going to have to add 95% alcohol. This will be very quick, only 10 seconds. This is called the decoloration process. So finally, we're going to do counter stain with saffron. And saffron also 60 seconds. Now, very importantly, I want to mention something is that the time is flexible. Which means if you stain 45 seconds, you stain 75 seconds, it's not going to make a big difference. but the procedure is fixed, which means you cannot mess up with the procedure. If you messed up with those 4 procedures, you'll get a totally different results. That is important. Okay, one more thing we want to mention. Because gram stain is based on the theory of cell wall, so when we're using a gram stain, those bacteria has to be very young. What means very young? It's grows 35 degrees Celsius, 24 hours. If you use an older culture, let's say more than 72 hours, what will happen? The cell wall will start to cracking down. The peptidoglycan will be started to breaking down. What will happen? Cannot hold on crystal violet. So everything stains like a gram negative or pink. We call gram variable stain. Which means everything stays like a gram negative. If it's older culture. Okay, that's something I want to mention. And I also want to mention one more thing is that the gram stain, when you finished, we will be using 10x to find specimen. And then we will move to 100x with oil immersion. We are going to find the sample. What are the 3 major items we need to recording as a complete gram stain results is number 1, gram reaction. Obviously, positive or negative. This is everybody knows. The second item is cell morphology, which means a shape. It could be a coxal, could be a large, or vibro others. Number 3 is cell arrangement. That could be single, could be a diprocoxal, could be 4 of them stacked together. We call it a tetrade. It also could be a chain, like streptococcus. Is that right? That could be a chain. It also could be like staphylococcus. Looks like you buy a bunch of grapes in the store. We call it a grape shape. So these are something called cell arrangement. These we have to record. Lots of you will remember gram reaction, positive and negative, but for the others you may forget about it. Okay? So this is what I have for the opening remarks. Now, the same thing, I'm going to show you how to do the gram stain. And I'm still going to using this lab section as an example because it's very important we get to know how to do it. Okay? So everybody come into the front desk and we're going to do the gram stain real quick, showing everybody how to do it. Just right here is good. And we need a glass knife. I'll have one. So first thing early in the morning when you came here, not really early, it's still 9:30, 10-ish. So clean the bench first. You could grab the microscope because it's going to be using anyway. Okay. We usually will do, just go there a little bit. There will be turn on the water slightly, make sure the water is working. And then you have a glass slides like this. Make sure it's clean. Okay, so we're gonna draw a two big circle. Two big circle right here, and write EC on the side, LF on the other side. So we're gonna be flip them over. Okay. Now we're gonna practice to using the Bunsen burner again. We need to make sure we have a hockey stick. Could be. Hopefully the gas is working. If it's not working, you turn it off immediately. So the gas. We'll try that. That may be working. So it works. It's good. That's a good amount. Okay, now we have a loop. So what's important for that? Make sure it's straight. And we're gonna flame it first. Because more or less I have some bacteria there. Okay, now we're gonna get some water. So just get some water. One drop. Another water. Two drops. Okay. Now we flame it again. Now we're gonna put the bacteria. Let's put the E. coli first. So little finger. Go down. You pick the bacteria right there. I'll pick a little bit more. Okay. And then make a big smear. Same thing like you did it before. Make a big smear. Okay, flame the loop. And we're gonna do lactobacillus. Go down. Don't block it. I saw that some people damaged it last time. That's not very nice because we have several labs until 4:30 in the afternoon. Okay, now we need to do air dry. So flame the loop. This is not gonna use it. We're gonna do air dry. Let's say the air dry. The time is ready. Let's follow this. We're going to do the heat fixing. So the heat fixing will be real quick on the top couple of times. And I mentioned it's not like cooking, but we have to make sure it's heat fixing, okay? Okay, let's say heat fixed. So we turn this off, and then go this way. We're going to start to do the gram stain. And make sure you do the gram stain. You have to wear a goggle because we'll touch the. Just give me the goggle. Thank you very much. Put this on the side. You can see whenever you touch the dye, wear the goggle. Now, the first time you do the gram stain, make sure it's in order. Crystal violet is very purple color. Second, the gram iodine looks like it's a brownish color. Then the alcohol. Now make sure it's very important. It's 95% alcohol, but it's not acid alcohol. Because acid alcohol is using for acid stain, it will remove everything. And the counter stain with saffron. So this is the order. You should be ready. Okay, I'm doing this for 20 years, so I know. But you first time do, you need to know the order. Okay, this procedure is simple. Crystal violet. So you add a drop of crystal violet right in the middle. Okay, this is not too much left. Okay, crystal violet. Staining 60 seconds. You can count Mississippi for 60 seconds, but you don't have to really do that a long time. I'll say 60 seconds is ready, so we're going to do rings like that. Okay. Okay. The second thing what we're going to do. Draw the water a little bit like this. So we're going to do gram iodine. So the gram iodine we'll put there to make sure the stain stays stronger. Iodine. Let's say the 60 seconds is ready. So we're going to rinse it. Oh, that's not good. This may not be good. Then we're going to be Decoloration is alcohol. That's real quick for 10 seconds. We're going to count 10 Mississippi. And we rinse it. And then we counterstain with saffron. That will be staining 60 seconds. Not sure this one is good because this is already being in the sink. So 60 seconds, let's say over 60 seconds is ready. So we rinse it. And then you make sure it's dried. And it's ready to go. We'll see whether this one is good or not. We'll see in a second. Okay. See whether this one is good or not, whether it's E. coli or it's a contaminated bacteria. Sometimes it happens it's not E. coli. So let's see. We're going to be using this microscope again, and also this is a time to practice you using microscope. Okay, so we're using. It's not really a permanent marker. Looks like it's already been faded lots of the places. So, okay, turn it on all the way to the bottom. For the arrow are grammar 10. So we go up to the place we can now move. And then let's see what we find. Okay. So you can come here to see what it looks like. This is underneath a 10x. You're not going to see much, but you could definitely see some of the dots there. Can you go ahead and see it? Okay. Can you see it? That's underneath 10x. So we're going to add oil. So oil immersion, we just one twisted, that's 40x, don't use it. One more twisted. After Labor Day, you still should remember. Two more twisted, and then we add a big drop of the oil. I'll just add oil there. Let's see what it looks like. Then we do go here, and ideally, only very minimal adjustment. Or what you find? Okay. It seems like supposed to be gram-negative, but we find it's a mixture of the purple color and also some pink color. So looks like this pathogen, this E. coli could be cross-contaminated. It's large, and you see a lot of pink color there, but you also see lots of the crystal violet color. Can you go ahead and see it? Is that right? It's some pink, some still purple. So looks like it's a mixed culture. Can you see it? That's what we want you guys to do, to report it. So ideally it's gram-negative bacteria for E. coli, but your results maybe looks a little bit different. That's what you should record. It could be the slants is get contaminated. Now let's go ahead to see the lactobacillus, what it looks like. Okay, lactobacillus should be gram-positive. So we'll see what it looks like. It maybe works, maybe doesn't work at all. Maybe it's rinsed off. So I didn't find anything, so I have to readjust. So let's go down to see whether we find something. And because remember, it was a little bit off, so we're going to see whether I can see it. And this lactobacillus, actually, you can see it's a lot of the dots. So I believe this lots of the coxae. I didn't see a very much of the where is a lot. So this lactobacillus could be some coxae, but it's gram-positive. So go ahead to see it. You can see some of the coxae there. Is that right? You can see some cocktail, it's gram-positive. Absolutely, it's gram-positive. It's pink, it's purple color. So that may not be lactobacillus. That's why I want to tell you, every year there's some culture which is messed it up, so you can find it what it is. And in your report, you should say, lactobacillus is gram-positive lots, E. coli is gram-negative, single lots. However, what we find is a little bit different. And what's the reason? It could be the cross-contamination of the slants. Okay, but you'll see, because every slants might be different. So that's give you a good practice to see what it is looks like. Okay, that's good. That's what we have. So today's work.